Hi guys, in this video we are going to be looking at exercise 12 of the electromagnetism tutorials. So we have the equation that's been displayed to us, so let's try to come out with a diagram that is going to help us to solve this question. So beginning with the A part, which we are finding theta, I just suppose the angle to be theta. Now we begin with our diagram. We have our reference frame, we have the Z, we have the Y, and then we have the X. Now we have a long piece of wire which has the mass of this and the length of this, used to make a square of side this. The coil is hinged along a horizontal side, so I represent it as this. Now from there we are finding theta, which is the angle that the plane of the coil makes with the vertical. To find that, I will first of all look for the angle that it makes with the horizontal, and I'm going to call it beta. Now letting that angle to be beta, we simply see that theta plus beta is 90 degrees. It is clear. The current moves in this direction. Here is the center of the square, therefore the weight is going to act vertically downward, so I call it mg. So theta plus beta being equal to 90 degrees, it means theta is 90 degrees minus beta. So our objective now is to find beta. So if we take torque due to the magnetic field, now the magnetic field causes anti-clockwise, causes the coil to move in the anti-clockwise direction. So with that we get NIBA sine beta. N is the number of turns which we are going to look for. I is the current, B is the magnetic field strength, and A is the area of the coil. Now we can also take moment about the x-axis due to gravity, where we have our weight mg times its perpendicular distance from this axis, which is the perpendicular distance from the x-axis. Now that distance, we represent it this way, but we know this distance. If I call it, for example, let me say a0, it is simply, since this is the center, it is simply the total length here, which I can call it a divided by 2. Now we can use trigonometry because this forms a 90-degree angle, so this here is actually going to be a0 times the cosine of beta, because it is the adjacent. But a0 is a divided by 2, and we know a as 0.1, so we have mg times its perpendicular distance, which is a divided by 2, the cosine of beta. Now at equilibrium we have this condition, meaning this minus this is equal to 0. So just express, we look for the tangent. Remember, our a here is the area of the coil, which is a squared, so one of the a's takes care with what is in the denominator, and we are left with a there. Now the number of turns, which is n, is simply the length, which is 4 meters, divided by the perimeter of the figure. The perimeter is the sum of all the sides. Since it's a square, there are 4 sides, so we have 0.1 times 4, which is 0.4, so there are 10 turns. So with that, we just replace the respective values, and we get beta to be tangent inverse of 14.41, which is 86.03 degrees. But we are looking for theta, which is 90 minus beta, so we get theta, which is the angle that the rod makes, the plane of the coil makes with the vertical at equilibrium, to be 3.97 degrees. The second part is asking us to find the torque acting on the coil due to the magnetic force. So it is either this or this, because they are the same. If we use this, we just need to replace the various values, replacing beta with 86.03 degrees, or replacing it here, and then we find the cosine. We are going to get the same value of 3.39 times 10 to the negative 3 Newton meters magnitude. So that is it for the torque acting on the coil due to the magnetic force at equilibrium.